Hey there, welcome back, and this is Cellular Network Parts 2. And if you don't watch the first part, then I'll encourage you to watch the first part first in order to understand this one better. And so let's start from where we left off. Like always, let's get started. We know that the key feature of cellular network is to reuse its frequency to increase both network coverage and its capacity. And as we had discussed in previous video, that adjacent cells must use different frequency, but if they're using the same frequency, they must be far apart. And the elements which determine the frequency reuse is called reuse distance or reuse factor. Hope you understand it. And to calculate this, we can use this formula. So let's not get mathematical because I don't like math. Do you? I don't like math because everyone who like math becomes something like I don't know. That we had discussed earlier, that frequency reuse is the factor where we use the frequency in the same network, and it can be 1 upon k and can be calculated with this formula which we had discussed. And where 1 upon k, I mean where k is the number of cells which cannot be reused in the same frequency, so it is reused. I think it's getting a little bit complicated, so I don't want you to get confused. So let me give you a practical theory about this. Suppose there are n number of antenna on a base station. Not a base station, suppose there is base station. Or if someone is getting confused in assuming base station, that suppose a roof. Suppose there are n number of antenna on a roof, and both have different directions, like this. I'm showing in this picture. Like there are n number of antenna on a roof for base station, and each of the antenna have different directions. Then they are serving n number of sectors. Each direction is equal to 1 sector, so the frequency reuse factor will be n by k, where is number of cells which we have discussed, and n is number of sectors. So hope you get that. So moving on forward, and if you don't get that, the comment box is all yours. The site is all not yours. The suggestion box is all yours. Query box is all yours, and everything is yours on the server. So let's move on. And let me tell you that if there is bandwidth b, then each cell can use a frequency corresponding to bandwidth b upon k, and a sector can use b upon n into k. And do you know that CDMA based system, I'm changing the topic or moving on forward, the CDMA base station uses a wider band to achieve the same rate as in FDMA. And if you don't know about CDMA and FDMA, then I'm repeating again. I'll encourage you to watch the first part. And where was CDMA based system use the same band to achieve the same rate as FDMA. This is compensated for the ability to use frequency reuse factor. And let me show you more clearly. Adjacent base station can use same frequencies, and that means different base stations and the users are being differentiated by codes rather than frequencies. And n is equal to 1 does not mean the CDMA only has 1 sector. It means that entire cell bandwidth is also available to each sector individually. And if we talk about taxi system, the frequency is not possible in same cities, but it is possible in different cities, and it can be also possible in big cities such as Mumbai, New York. Why I'm giving examples of cities. So I should move on. Moving on forward to OFDMA, which uses LTE network. LTE network, you must have noticed in top of your smartphone. And these type of network are being deployed with frequency reuse factor is equal to 1. Such type of network do not spread over the whole frequency band, and for that, inter-cell radio resource management is too important to coordinate resource allocation between different cell sites to limit the inter-cell interference. I mean this is done to limit or to prevent the inter-cell interference between the cells. So let's have a look on cellular network map and let's study about that. Here's a cell network map with telephone tower located at the corner of hexagon where 3 cells are at converge. Each are aimed at 120 degrees. You can see here and dividing into 3 different cells with different frequencies. This provides a minimum of 3 channels and 3 towers of each cell, increasing chances of receiving usable signal from at least one different direction. Why I use different? I just meant that this increase the chances of receiving usable signal from at least one direction. Cell phone companies use directional signals to improve reception along highways and inside buildings like stadiums and arenas. You must know this. We all have heard about the term broadcast message, and I don't think there's something to tell you going deep, but I have to tell you. Okay, I'll just give you one simple example that you understand. We all have received messages from our school of assignments, of homework, of complaints, of holidays. That message is called broadcast message. The most important use of broadcast information is to set up the communication channels one-to-one. I mean to say that the most important use of broadcast information is to set up channels for one-to-one communication, one-on-one, man-on-man, 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 man-on-man. I repeated too much time. Okay, let's get back. What the? So let's discuss again that example of taxi system. And suppose the taxi is moving far from one tower and moving closer to another tower, then he will change frequency manually. And if he missed any message or any kind of error occurred, and he will ask base station master to repeat the message on the different frequency. But in cellular network, the frequency is changed automatically, electronically, without any interruption when a mobile transceiver is moved from one cell to another cell, and this is called handcuff. And it means that frequency is being changed when we take our phone from one cell to another cell. So I think that's enough for today. I'll encourage you to rewind the video in order to understand it better. And if you don't get any topic, then you can contact us. There are so many ways of contacting us, and I repeat every time. You can comment down, or you can go to our website and fill out the form. You can go on Facebook page, Instagram, and the Twitter. Choose anything. We'll catch you. So see you again.